Today's lesson is going to be on proving special parallelograms. So for today's lesson, we're going to look at a parallelogram and then find a way to prove that it is either a rectangle, a rhombus, or a square. So what's really important here is that for this lesson, we are assuming that the quadrilateral is already a parallelogram, and then we want to prove that it's a rectangle, a rhombus, and a square. If we didn't already know that something was a parallelogram, then first we would have to prove that it's a parallelogram using one of the methods that we've talked about earlier to show it's a parallelogram, and then show that it's a rectangle, rhombus, or square. But again, with today's lesson, we are going to assume that everything we already know is a parallelogram. So if we want to prove that something is a rectangle, then we can show that one angle is a right angle, or we can show that the diagonals are congruent. Either one of those methods would work. So we don't have to show that all four angles are a right angle. We just need to know that one angle is a right angle. If we were looking to prove that something was a rhombus, we could show that one pair of consecutive sides are congruent. So we don't need to show that all four sides are congruent to each other, just one pair of consecutive sides. So they have to be next to each other. They can't be opposite sides, are congruent. We could show that the diagonals are perpendicular, or that the diagonals bisect opposite angles. And then if we wanted to show that a parallelogram was a square, we're going to show that the parallelogram is a rectangle and a rhombus. So we can pick one of these to show that it's a rectangle, and then one of these methods to show that it's a rhombus. And if a parallelogram is a rectangle and a rhombus, then that makes it a square. So for this first side of this worksheet, we are just going to look at diagrams and classify these parallelograms using the most specific name. So we can technically call all of these parallelograms, but we want to classify them as being a rectangle, a rhombus, and if it is a square, we want to use square because that's the most specific name that we can give it. So for number one, I'm looking at this parallelogram, and what I notice here is that my diagonals form a right angle, which means they are perpendicular. So that means that this figure is going to be a rhombus. So I'm going to say that this is a rhombus. And my reason is that the diagonals are perpendicular. Okay, for number two, I know this is a parallelogram, and here I see that this side on top and this side on the right side are congruent. So this is one pair of consecutive sides being congruent. So I can say that this is a rhombus because we have one pair of consecutive sides congruent. Just going to abbreviate a little bit there. Okay, there's nothing in number two that tells me this would be a rectangle, so I can't show that it is a square. All right, for number three, I have this parallelogram. I see a right angle in my corner. So if I have one right angle, that is enough to tell me that it's a rectangle. And we can say that's because we have one right angle. Number four, if I'm looking here, I see that my diagonals are perpendicular, which means this is a rhombus. Okay, so this is a rhombus because we have diagonals perpendicular. But then if I look at those diagonals, I also see that each segment is congruent to the other piece. So the diagonals are not only perpendicular, but they're also congruent. So this would be a rectangle because my diagonals are congruent. So the most specific name that I can give this special parallelogram is a square because it's a rectangle and a rhombus. If I look at number five, I have this parallelogram. I see that my diagonal here bisects the opposite angles. So this would be a rhombus. So again, the diagonals bisect the opposite angles. For number 6, I'm looking again, this segment is congruent to this segment is congruent to this segment. Both diagonals are congruent to each other, so this is a rectangle. Because we have diagonals congruent. It doesn't tell us these diagonals are perpendicular. It doesn't give us any more information with that, so we can only classify this as a rectangle. If I look at number 7, I have this piece of my diagonal congruent to this piece congruent to this piece, but it actually isn't enough to show that the diagonals are congruent. I don't have any information about either the diagonals or any of the sides being perpendicular. So here, for number 7, I can actually only show that this is a parallelogram. There's not enough information to classify this as a rectangle, a rhombus, so then it can't be a square. And even though it looks like these are probably 90-degree angles, unless I have that marking there, I cannot say that it's a 90-degree angle, so I can't say that it's a rectangle. And then if I look at number 8, here I know this is a rectangle because I have my right angle. So I have one right angle. I know this is a rhombus because I have my consecutive sides congruent. So again, because this is a rectangle and a rhombus, the most specific name that I would want to give this special parallelogram is a square. Okay, so this was proving special parallelograms just using diagrams and markings and these properties up here. Now we're going to look at how to prove these special parallelograms on a coordinate plane. So again, we are assuming here that we know these quadrilaterals are parallelograms. So we don't have to prove that. We're just going to prove that it is one of the special parallelograms using these methods below. So for a rectangle, we can show that there is one right angle using the slope formula. So what we can do is we can show that the sides are perpendicular. I'm going to use the symbol for that. So if our sides are perpendicular, it means the slopes are opposite reciprocals. Or we could show that the diagonals are congruent using the distance formula. Okay, I prefer this method here for a rectangle because I would rather use the slope formula or use rise over run than having to use the distance formula. But totally up to you which method you want to use, and sometimes it will tell you specifically which one to use, so you should know both. Next, if we want to show that something is a rhombus, we can show that we have one pair of consecutive sides being congruent. That is again using the distance formula. So we could show that there's the same distance between those 2 points. Or we could show that the diagonals are perpendicular using the slope formula. And again, we're looking for the slopes to be opposite reciprocals because that would mean that they are perpendicular. All right, so that is the one I prefer. I just prefer using the slope formula. And then if I wanted to show that something was a square, I would want to show that the parallelogram is a rectangle and a rhombus. So I would have to pick one from this column and one from this column, and then I can say that it's a square. So let's try some practice. Here it does not give us a specific method to use, so I'm going to try to do kind of a mix of different ones here. So this first one has parallelogram A, B, C, D. So the first thing I'm going to do is plot these points. So I have -2, 2. Oops, that's the wrong marking there. So we have A, and then B is 1, 6. C is 6, 6. And then D is 3, 2. Okay. Now, once I have this parallelogram plotted, I'm going to go out on a limb here and say this is not a rectangle, right? So if I look to find that the slopes are perpendicular, I can see right away that the slope of segment BC is 0, the slope of segment AB is not undefined, right? So that slope is actually just 1. So this right here is not a rectangle. All right, which again, you can probably assume that just from the image and how it looks. So now we're going to show that this is a rhombus, or check to see if this is a rhombus. So what I could do here is check the distance formula. So like I said, I am going to try to do a mix of all of these. So because I have this horizontal line, it's not too bad using the distance formula. I can literally just count and say that BC is 5 units long. Okay, just by counting. And then if I look at AB, all right, if I wanted to use the distance formula there, I'm going to have 3 minus 6 squared plus 2 minus 6 squared. So that's going to be negative 3 squared plus negative 4 squared. So negative 3 squared is 9, plus negative 4 squared is 16. And I get the square root of 25, which is 5. So segment AB is 5 units and segment BC is 5 units. So because I have one pair of consecutive sides being congruent, I can show that this is a rhombus. So let me do this in a different color. I'm going to say we have a rhombus and we have one pair of consecutive sides congruent. Okay, because this was not a rectangle, that's all we can say. We can't say it's a square. Now let's look at number 2. So number 2, we're going to plot this here. We have negative 4, 0, negative 3, 3, 3, 1, and 2, negative 2. All right, so let me make these straight points or straight lines. Okay. So here, this kind of looks like it's going to be a rectangle. Again, this is something that we want to prove. So I'm going to use the slope formula. All right, so the slope of segment AB, I'm going to use rise over run. So I'm going up 3 over 1. So the slope of AB simplifies to 3. I'm going to find the slope of BC. So I'm going down 2 and to the right 6. So that's going to simplify to 1 over 3. Okay, so these are opposite reciprocals. So I can say that this is a rectangle. Because we can say that angle B is a right angle. And in parentheses, I'm just going to put that the sides are opposite reciprocals. So again, that's how we know that this is a right angle, because we have perpendicular lines. They are opposite reciprocals. Now I can see clearly here this is not going to be a rhombus, so I'm not going to check to do the distance formula right now with segment A, B, and BC, because I can see here this is pretty clear. This one is not going to be, they're not going to be congruent. Okay, so let's check number 3. So number 3, we have negative 1, negative 1. We have 1, 2, 3, 2, 4, 6. All right, this point here, B. C is going to be 2, 5. And D is 4, negative 2. So I'm going to plot and make that parallelogram. Okay, so first thing I'm going to check to see is if this is a rectangle. So if I find the slope of AB, that is negative 8 over 2. I'm sorry, I think that's -7. Let's see, 2, 4, 6, yeah. -7 over 2. Then I'm going to look at the slope of segment BC. So that is -1 over 5. So this is not a rectangle because those sides are not perpendicular, so I don't have a right angle. Now I'm going to look to see if this is a rhombus. So I'm going to check and use the diagonals being perpendicular just to kind of go with the slope formula there. So if I look at AC, I would be going up 1, 2, 3, 4. Let's count again. 1, 2, 3, 4, 5, 6 over 2. So the slope of diagonal AC would be 6 over 2, which is 3. And then the slope of BD, so I'm going down, let's see, 6, 7, 8, and then over 1, 2, 3, 4, 5, 6, 7. So I went down 8 over 7. If I look here, these are not opposite reciprocals either, so this is not a rhombus, which means this is just going to be a parallelogram. So let me do this in another color. We're going to say this is a parallelogram. And we're just going to say not a rectangle or a rhombus. Okay. And for our last problem, we have parallelogram ABCD. We're going to plot our first points here. So we have A at -5, 1, B was at -2, 6, C is at 3, 3, and D is at 0, -2. All right. So first I'm going to see if this is a rectangle. So the slope of AB is, we're going to go up 2, 4, 5 over 3 is the slope of AB. The slope of BC, I'm going to go down 3 over 5. So if I look at my consecutive sides, they are perpendicular, which means this is a right angle. So here I know that this is a rectangle. Now I want to check to see if this is a rhombus. So again, I'm going to stick with the slope formula because I just prefer that over the distance formula. So I'm going to look at the diagonal AC, and let me draw this in. I'm going to draw this in a different color here. So I'm drawing those diagonals in blue to try to help us. So the slope of segment AC, I'm going up 2 over 2, 4, 6, 8. So up 2 over 8, that's going to reduce to 1 over 4. And then the slope of segment BD, I'm going down 8 over 2, which simplifies to -4. So I know that this is a rhombus and a rectangle, which means this is going to be a square. And we can say because it is a rectangle and a rhombus. Okay, so that's how you can prove different special parallelograms given that you have a parallelogram. Again, if you didn't know that it was a parallelogram and you just knew it was a quadrilateral, first you would want to prove that it's a parallelogram, and then you could use one of these methods to prove either a rectangle, a rhombus, or a square. So thank you so much for watching. If you have any comments or any questions, you can post in the comments below. Thank you.